What's up, guys? Today we're doing a video on exponential function word problems. And we're going to do a few different things. We're going to, first of all, write an equation or write a function based on a word problem. We're going to use that function to make a graph, and then we're going to answer questions about the situation using our graph. Now later on we will be solving without using a graph, and it's going to involve some special techniques, but for now we want to focus on using that graph. So here's an example. It says a town has a population of 13,500. Its population is expected to grow by 3% per year. The first part says model the population over time with a function. Now I already went ahead and wrote it in here. The function, in this case, we're going to say f of x equals the starting population, 13,500, times 1.03 to the x power. And if you're not sure where the 1.03 came from, you need to go back and watch the video that was before homework 1 in my homework 5 in my unit 5 section. It was about percent increases and decreases, and the short story is 3% more than 1. We're multiplying by 1.03, which is 3% more than 1. Again, go watch that video if you need more help on where that number came from. So once we have this, we can actually make a table and use that table to plot some points and see what this graph looks like. You could plug in the years 0, 1, 2, 3, and so on, and make the points by hand, but I'm just going to go ahead and use the table in my calculator to do it.
Okay, so as you can see, I have my function typed in, and if you're using the smaller calculators, the multi-views, again, it'll be very similar. You should have used the table by now. It'll be very similar to how you enter it. You may have a couple different windows to go through, but the output should be largely the same. We're only using the table and not the graph. So once I have my function typed in, what I want to do is I want to hit second and go to table. And if you're using the multi-views, again, you'll just hit enter and it'll pretty much take you straight to the table. And you can scroll through here and see some different points which represent the years in the X column and the population in the Y column. You can see at year 0 we have our starting population of 13,500. At year 1, the population has increased by 3% to 13,905, and so on. So what I want to do is I want to use these points, and I want to plug those into the graph.
Okay, so I've made the points on the graph based on what we saw in the table, and I'm going to use this to answer the questions. Now you could just go ahead and draw a line through here. I'm just going to leave it like this for now. And notice that it doesn't exactly curve like you would expect an exponential function to. Well, it does, but we're kind of zoomed in so far on this graph that we don't really see it because the growth percentage is pretty small. It's only a 3% growth. If this number were bigger, you would see more of a curved shape, and the faster it's growing, obviously the faster it's going to curve up. Okay, so it says predict what the population is going to be in 5 years. So you can actually do this on the table. Okay, I could go look at the table and see what it says, or I could use the graph. And if I drew it accurately, I should get a pretty good idea. It looks like it's somewhere around 15,500. If I look at my table, the table actually says, and if you look at the numbers you wrote down from your table, it says that when x is 5, y is 15,650. So using the table, we can actually get an exact answer. It's 15,650. And you can see on our graph that's about right, because that's where I put the point. It's about halfway between 15 and 16. Okay. Now another question is, in how many years will the population reach 17,000? So again, going to the table, you'll notice that at year 8 it reaches 17,100. And look at here, you see, so at 7 years it's still about 16,000 and a half. It's actually 16,600 still. But at year 8 we're just over 17. So what's the answer? Is it 7 or is it 8? Well, at year 7, it's not yet 17,000. But at year 8, we will have crossed the threshold of 17,000, so we're going to say in 8 years. Now, in reality, it's going to happen somewhere between 7 and 8 years. Okay, and that's where, once we get to a way we can solve these algebraically, then there will be a method that we're going to learn about using logarithms, which will allow us to find an exact answer, and it will be 7 point something years.